Okay. With your group, I want you to take these 2 slices of pizza that I have given you. I've given you information about both. One, the first slice of pizza has an angle of 60 degrees. The length of it, so the radius of it, is 6 inches. And it costs $1.50 for that slice. Our second slice of pizza has an angle of 45 degrees with a radius of 7 inches, but it's $1.70 for that slice. And in the next 2 minutes, I want you to talk with your group and come up with which slice of pizza is the best value, so which one's the most cost effective, and why. You have to have a reason. Okay? Your reason cannot be because the $1.50 one's cheaper. That's not a reason. So logically process through what would make one slice of pizza a better value than the other. Okay, so we're going to take a couple minutes to do that. I'm going to ask for a volunteer first, and then I'm going to volunteer people. So, who can tell me what slice of pizza they chose and why? No one's volunteering, so you're going to be voluntold?
I think it's the $1.50 because it's 60 degrees, which is more wider, and you're getting if it's wide, you're getting more out of it. But even though the 7 inches, it's longer, but it's still shorter, which is 45 degrees. It's less than 60, so I'd go with the wider.
Okay, so you're going with the first one because it's wider than the second one. Even though it's not quite as long, it's still a bit wider, so you think there's more pizza in the first one. Okay? Someone else. Choose pizza and why? No? Voluntold? Bess. Which pizza do you think and why? Okay, the 7-inch pizza, why? Okay, so the opposite, basically the opposite argument is Brandon, right? It's longer, so that one's probably a better value. Okay. Someone else have a different pizza, Armand, and why?
I feel like they're both the same.
You feel like they're both the same? Why?
I mean, it's longer, and that one's fatter.
Okay.
They both have the same, same thing.
Okay.
Just
So
different
one's
shapes.
longer, one's fatter, so it's probably the same.
Yeah.
Okay. Yeah.
We found the area of each slice of pizza, and the 60 degree with 150 was higher.
You found the area of each slice of pizza. How did you find the area?
Using the 60 degrees, well, we put 60 over 360, and we multiplied it by 2 pi.
Okay, so you didn't find the area. What did they find? So they found the arc length. So you found the length of the, what is the arc of a pizza? The crust, right? So a couple people did that. You found the length of the crust. So let's talk about that for a second. If you found the length of the crust for this pizza, how much crust did you get for the $1.50 pizza? Say that one more time. 6.3?
Yeah.
Okay, so 6.3 inches of crust. How much crust did you get for the $1.70 pizza? 5.5? Okay, so you're saying because there's more crust, then this pizza is obviously a better value. Okay. There's no wrong answer right now. There will be in a second when I teach you actually how to solve this problem. Okay, so we're kind of all over the board, but the point is I want you to kind of process through and think about what you know and how you can apply that information. So let's actually figure out how we can solve it. Go ahead and flip to page 33 of your notebook. Okay, today's lesson is on sector area. What do you think sector area means? Area of a certain part of the circle. So if I have a circle or a slice of pizza, or I have a pizza, and I want to know the area of a slice, I'm going to be finding sector area. So I'd be looking just for the area of this piece. So arc length, remember we found a piece of the outside of the circle. Now we're finding a piece of the area of the circle with sector area. For sector area, we're going to need a few things. We're going to need to know the measure, just like we did before. Who remembers what the measure is equal to? Just in case it's not here for us. The central angle. So the measure and the central angle are going to be the same. So if I know what the central angle is, I know what the measure is. This is still my radius, right? It goes from the center of the circle to any point on the circle. So that's still my radius. We do have a new formula though. It's not too bad. Ready? So our formula, m over 360. So it's that piece over the whole thing, which is 360. And what are we looking for in this case? The area of it. So we'll multiply that piece times pi r squared. So for arc length, remember we did m over 360 times the circumference formula, 2 pi r. This one's m over 360 times the area formula because we're looking for area. Does that make sense? Okay. So let's try one. So we're going to find the area of this whole piece. What two pieces of information do we have to find the area of that piece? What do we need to know to plug into our formula? The measure. What's the measure? What is the measure? 315. So my m is 315. And what else do I need to know? The radius. And what's the radius? 14. Just like in the last lesson, the calculator does all the math for you. So it's important that you're writing down what you're plugging into your calculator, just in case there's a user error. I can still give you partial credit. Okay, so in our calculators, we're technically plugging in 315 over 360 times pi times my radius squared. And before I get calculator happy, I'm going to simplify. Whoops. So 315 over 360, what's 14 squared? 196. So this is what I'm plugging into my calculator. You're going to have two answers still, your exact and your rounded. So in your calculator, 315 divided by 360 equals, leave it there, and then multiply it by 196. Does that say 171.5?
Yeah.
So sector area is 171.5 pi. And what do you think my units are? Feet squared. It's still area. So feet squared. And then if I want my exact answer, I'm going to multiply the 171.5 by pi and end up with what? To the nearest tenth. 538.8. Good. Feet squared. So it's all formula. It's being able to plug those pieces into the formula and use your calculator appropriately. Why don't you try this one? Okay, you're going to find the area of that sector there. So take a couple minutes with your group or by yourself and do that. All right, let's see how we did. So first thing we need to know is the measure. What's my measure? 135. What's my radius? 12. So 135 over 360 times pi times my radius squared simplifies to 135 over 360 times 144 pi, because I squared 12. So in your calculator, 135 divided by 360 times 144 gives you what? 54. So 54 pi miles squared would be your exact answer. And your rounded answer to the nearest tenth would be what? 169.6 miles squared. We feel okay about that?
Yes.
Okay. I know we love word problems, so we're going to try one. And you're going to write it out because it's only one. We ready? Okay. So you're writing out the word problem. A circular plot with a 180-foot diameter is watered by a spray irrigation system. We'll talk about all the pieces in a second. So a circular plot with a 180-foot diameter is watered by a spray irrigation system. What is the area that is watered as the sprinkler rotates through an angle of 150 degrees? I'm sorry, of 50 degrees. So a circular plot with a 180-foot diameter is watered by a spray irrigation system, basically a fancy sprinkler. What is the area that is watered as the sprinkler rotates through an angle of 50 degrees? So as soon as you write that out, I want you and your group to come up with what that picture looks like. I don't want you to solve anything yet. I want you to draw what that picture looks like. Part of the problem that we have with word problems is we don't know what it's asking us or what things look like, and so then it becomes daunting and it's not something that you want to try. So take a second and figure out what it looks like. So a circular plot has a diameter of 180 degrees. Nope. Well, yeah, technically. What's the area if the sprinkler rotates through an angle of 50 degrees? So what do you think that looks like? Hopefully you have pencil so that just in case it's wrong, we can fix it. So take like a minute and draw what that looks like. A circular plot. Step one would be to draw a circle. If you don't have a circle, then you're way off. Okay, so a circular plot has a 180-foot diameter. What does that mean? Goes all the way through the circle. And this is 180 feet. Okay? Hold on. All right, hold on. what is the area that is watered as the sprinkler rotates through an angle of 50 degrees? So we only care that this piece of land is getting watered. We don't care about the rest. So it rotates through this 50-degree plot. And that 50 degrees can be anywhere. It doesn't have to be on top. It can be anywhere in your circle. Okay. Now, there's a piece of information that they don't explicitly say, but that is super important. Because in order to find sector area, what pieces of information do I need? The radius and the measure, right? What's the measure? 50. What's the radius? 90. The diameter is 180, which means my radius is 90. Are we okay with that? So if the diameter is 180, half of the diameter gives me the radius. Now I can plug it in. So 50 over 360 times pi times 90 squared. What is 90 squared? A big number. What's that big number? 8,100. So this is what I'm plugging into my calculator. In your calculator, 50 divided by 360 times 8,100. What does that give you? 1,125 pi feet squared. So that's my exact answer. And then take that and plug it in. So 1,125 times pi. What is your answer rounded to the nearest tenth? 3,534.3 feet squared. Now that you know how to calculate sector area, I want you to go back to your warm-up and I want you to figure out which slice of pizza is the best value. So everyone needs to do some math and figure out what slice of pizza is the best value. I'm going to come back to you in like 2 minutes. Okay, so we use sector area to figure out the area of each of these slices. What was this area of the first slice of pizza? 18.8 inches, right? So that gives you 18.8 inches of pizza. What about the second one? 19.2 inches. Did you stop there and say that the second slice was better? No? How do we actually determine which one's better? Divide it by the price. Oh, so what is 18.8 divided by 150? 12.5. Okay. What's 19.2 divided by 170?
11.3.
So which one is the better value? The first one. Not only do you get more pizza, but it's also 20 cents cheaper. Okay? So now you can go to Costco or Little Caesars or Papa John's and no one can ever cheat you out of pizza. Because you could figure out, if you wanted to, which one's the best value. You're not going to do that? Costco's always the best? Okay. All right. A few announcements. So, I already said the test is moved to Monday. Okay, so you have an extra day for that. Tomorrow you're going to be working on a practice test. Okay. I will not be here, so you better be good. You're going to do your practice test in class tomorrow. It will be due Friday. We're going to put it in Edulastic and review it Friday and then test Monday. If you need additional help, there is math lab after school today, after school tomorrow, Talent on Saturday. Okay, so that's the first thing. Second, you do have homework. We have a little bit of time to work on it. it's in 2 pages. It's not like together. It's a front and a back, but they're on 2 different documents. So you need to make sure you do both documents. The first one I think is 9 questions, and the second one I want to say is like 8 questions. So it's not a lot, it's just separated. Does that make sense? Okay. So for the remainder of the period, you're going to work on your homework. I will project it. It will also be in Google Classroom.